We are going to solve simultaneous equations. The source of our question is a ZIMSEC paper written in June 2016, and it is a paper 1. ZIMSEC stands for Zimbabwe Schools Examination Council. The question reads, solve the simultaneous equations. 6y minus 3x is equal to 1. 3x plus y is equal to 13. So we are going to mark this as equation 1. And this becomes our second equation, equation 2. We are going to apply two methods. The first method is the method of substitution. Then we are going to apply the method of elimination. But as for the method of elimination, we are going to apply it twice. We are going to have two tiers. Tier number 1, we are going to apply the method of elimination as it is widely used. Then the second tier, we are going to apply the method of elimination by eliminating twice. Eliminating to find x and also eliminating to find y. So if you need to discover how these methods are executed, you can stay tuned and watch as we do it. The method of substitution, we are calling it M1. What we do here is, we are going to examine our equations. We have equation 1 and equation 2. What we need to do is, we are looking for a variable or an unknown which has the coefficient of 1. Because if a variable has the coefficient of 1, it is easier to make subject of formula. So let us look at equation number 1. The coefficient of y here is 6. The coefficient of x is minus 3. The coefficient of x in equation 2 is 3. And the coefficient of y is 1. So we have discovered that in equation 2, y is the coefficient of 1. We want to make y the subject of formula. So what we do is y is equal to 13. And this 3x is going to transfer from the left hand side to the right hand side. Because it is a positive, when it crosses over the equal sign, it's going to be a negative. So y is equal to 13 minus 3x. And we are going to label this equation 2a. Why did we say equation 2a? Because this equation, it's just the second equation. It's just equation 2, which has been written differently. We have made y the subject of the formula in order to apply the method of substitution. Now we want to substitute. The way we substitute is like this. We are going to replace y in the first equation with 13 minus 3x. We are going to substitute y in the first equation with 13 minus 3x. Technically, this is what we are going to do. We are substituting 2a into 1. Why are we substituting 2a into 1 instead of substituting 2a into 2? We cannot substitute 2a into 2 because 2a and equation 2, they are just the same equation written differently. So we need to substitute equation 2a into equation 1. How do we do it? We write it as 6. Instead of writing y, we substitute with 13 minus 3x. Then minus 3x, it's equal to 1. So this equation, it's just the first equation, but instead of writing y, we substituted with the bracket 13 minus 3x. Now we are going to solve this part by expanding the brackets. To expand the bracket, we are going to multiply every term inside the bracket with 6. So it's 6 times 13, which is 78. Then 6 times minus 3x, 6 of 18, it's minus 18x. Minus 3x, it's equal to 1. Then let us solve further it's 78, minus 18x minus 3x, it's minus 21x, it's equal to 1. Then collecting like terms means 78. This one is crossing over to the left hand side, becoming a minus 1, it's equal to, and minus 21x is crossing over to the right hand side, becoming 21x. Then solving on the left hand side, 78 minus 1, 77, it's equal to 21x. Then to isolate x, or rather to find x, we are going to divide both the left and right with 21. The effect is 21 here cancels out, equal to, then we need a factor which divides into both 77 and 21. It's 7. 7 into 21 gives us 3, and 7 into 77 it's 11. So x is equal to 11 over 3. This is our solution for x. We now need to find y. In order for us to find y, we are going to substitute x into either equation 1 or equation 2. But for the sake of proving this point, I am going to substitute x into both equation 1 and equation 2 to see if we find the same solutions. But in your examination, you are not required to substitute x into both equation 1 and equation 2. We are doing this for the sake of instruction. We calculated x and it gave us 11 over 3. We now need to find out what y is going to be. So let us substitute. Substituting into 1. We are going to replace wherever there is x with 11 over 3 in equation 1. We need to find out what answer we are going to get. So we write it as 6y minus 3. Instead of x, it becomes 11 over 3. So 3x becomes 3 times 11 over 3. It's equal to 1. Then cancel out 3 to remain with 6y minus 11 is equal to 1. Then collecting like terms, 6y becomes equal to, then minus 11 goes to the right hand side to become plus 11. So it's 1 plus 11. 6y, it's equal to 12. Dividing both sides with 6, y becomes 2, since 6 into 12 is 2. So substituting x into equation 1, we are finding y is equal to 2. Let us do the same for the second equation to see if it is true that it does not matter which equation you choose to substitute x into. You are still going to find out that y is equal to 2. Now we need to substitute into equation 2. So equation 2, we are writing it as 3. Instead of x, we are inserting 11 over 3 plus y is equal to 13. Then the 3 cancels out. To now we have 11 plus y, it's equal to 13. Then y will be equal to 13. Then the effect of transference makes 11 minus 11. So y is equal to 13 minus 11, which gives us 2. Again, our answer is going to be y equal to 2. I need to re-clarify that you are not required to substitute x into both equations during an examination. You choose either equation 1 or equation 2. I did what I did as an instructor for the sake of instruction to show you that it does not matter which equation you substitute into. You are still going to find the value of y being the same. The first tier 1 of our method number 2, and our method number 2 is the method of elimination. So tier 1, I'm going to demonstrate how elimination is taught. And the essence of tier number 1 is to prove to you or to show you that when elimination is taught, we do not eliminate for both x we do not eliminate to find both x and y. We just eliminate to find either x or y, then substitute what we have found to find the other variable. So this is going to be tier number 1. Tier number 2, we are going to eliminate to find x, then eliminate to find y. But when you are applying the method of elimination, you are supposed to, or rather I advise that you apply it as we are going to show you in tier number 1. What we do here is, firstly, we are going to rearrange our equations such that the values of y are aligned and the values of x are also aligned. This is what I mean. Our equation number 1 is 6y minus 3x is equal to 1. Equation 1. But for our equation number 2, we are starting with the value of x, then y. So rearranging, it becomes y plus 3x. It's equal to 13. Equation number 2. So equation number 2 has been rearranged in such a way that values in y are aligned and also values in x are also aligned. In our eliminating, we are going to make a choice. We are going to either eliminate y so that we are left with x, we calculate for x, we find x, or we are going to eliminate x so that we are left with y, we calculate for y, and we find y. Our decision should be informed. And what informs our decision is an inspection or just an observation of the two equations we have. We are going to ask the question, which one is easier to eliminate between y and x? If we look at y, we find that for equation 1, the coefficient of y is 6, and for equation 2, the coefficient of y is 1. But when we go to x, we have minus 3 and 3 for both equations 1 and 2 respectively. We can see clearly that it is easier to eliminate x because the coefficients are somewhat similar. It becomes a little difficult to eliminate y because we need further manipulation to make the coefficients of y similar. But how then are we going to eliminate x? We have minus 3x plus 3x. We are going to add. So it's add, put a bracket, then draw a line. What are we adding? We are adding what we have on the top added to what we have on the bottom. So 6y plus y, that's 7y. Then minus 3x plus 3x, we are going to get 0. And this is what we wanted. We wanted to eliminate x. And here we have successfully eliminated x. Because minus 3x plus 3x or minus 3x plus 3x, it's going to be 0. Then 1 plus 13 gives us 14. We are now left with y. We have successfully eliminated x. Then we divide 7 into both sides. 7 here cancels out. So we are left with y being equal to 7 into 7, it's 1. 7 into 14, it's 2. So y is equal to 2. And this is the same solution we found when we were applying the method of substitution. What then do we do now? Tier number 1. What we are supposed to do is, we are now going to substitute y into either equations 1 or equation 2. In method number 1, we substituted into both in order to prove that it does not matter which equation you choose. But here we are just going to choose either equation 1 or equation 2. So let us choose equation 1. We are going to substitute for y. We need to find x. Remember from our method number 1 that the value of x was 11 over 3. So if we work this correctly, we should find x as 11 over 3. So here 6 multiplying 2. This is y being substituted. minus 3x is equal to 1. Then 6 times 2 is 12 minus 3x being equal to 1. Minus 3x is going to be transferred and 1 also transferred. We are left with 12 minus 1 being equal to 3x. 12 minus 1 is 11, so it's 11 equal to 3x. Therefore, here divide both ends with 3. 3 cancels out here, so therefore x is equal to 11 over 3, which is what we found in our method number 1. So this is tier 1. This is how the method of elimination is applied. We do not eliminate for both x and y, we just eliminate for either. Then we end with substitution. But now let us introduce the second tier of the method of elimination. For the second tier of method number 2, which is elimination, we are going to eliminate y so that we find x. Remember, we have already eliminated x and we found out that y is equal to 2. We now need to eliminate y so that we find out what x is going to be equal to. We are going to follow what we did in our previous tier 1 of method number 2, rearranging so that both x and y are aligned. So here we have y plus 3x being equal to 13. And again, this is equation 1. This is equation 2. Our decision here is we want to eliminate y so that we find x. But there is a challenge, because in order for us to successfully eliminate y, we require that the coefficients of y be the same. So here the coefficient of y is 6 and here it's 1. What we have to do is we need to multiply the second equation with 6 so that the coefficient of the second equation becomes 6, similar to the coefficient of the first equation, which is also 6. So doing so, 6 times y, that's 6y, plus 6 times 3x, that's 18x, it's equal to 6 times 13, it's 78. And this is equation 2a. Now rewriting our equations, we are saying 6y minus 3x is equal to 1, equation 1, and 6y plus 18x is equal to 78, which is equation 2a. Now the problem has been mitigated because the coefficients of both y in the first equation and y in the second equation are all 6. Now to eliminate y, we simply need to subtract. So this is a subtraction. We are subtracting the first equation. Rather, we are subtracting the second equation from the first equation. Put our line here. 6y minus 6y, it's 0. Y eliminated. Minus 3x minus plus 18x. So when a negative meets a positive, the net effect is that we have a negative. So minus 3x minus 18x, that's minus 21x. It's equal to 1 minus 78, that's minus 77. To get x, we are going to divide both ends with minus 21. And here we are left with x being equal to, the negatives cancel out, then 7 into 21 is 3, 7 into 77 is 11. So x is equal to 11 over 3. Again, we got x as 11 over 3. The same we did when we applied tier 1 of method 2, and the same value we got it when we applied the method of substitution. If you have any questions pertaining to either the method of substitution or the methods of elimination, you can indicate in the comment section. If you found this video to be helpful, please subscribe, like and share so that the same help can be offered to others who are in need. If you have any other question, ordinary level mathematics related, be it is from ZIMSEC, which is the examination board in Zimbabwe, or it is from Cambridge, which is a more international examination board, or any other ordinary level mathematics question from other examination boards, you are free to send it directly to me. My contact details, they are found under the details section of this YouTube channel, or you can comment in the comment section. You can insert your question there, and I am sure to attend it. Otherwise, thank you and stay blessed.